So before starting this video, I'd love to thank the sponsor of this video, which is Code Studio. Now, if you are willing to practice interview problems topic wise, this is the place where you should look for, because Code Studio has over 2000 plus problems and has all the problem solution in C++, Java, as well as Python. If you're looking for a guided path, then you can find for Python, for DBMS, for object-oriented programming, operating system, computer networks, system design, web development, any other thing that you're looking for, you'll find guided paths for every other thing over here. Also, if you're looking for any top company questions, let's say if you have an interview at Amazon, if you're looking for Amazon questions, you can get all the top Amazon coding questions via tag and all the solutions in C++, Java, as well as Python. Also, if you have an interview schedule, you can read their interview experiences, where there are 600 plus interview experiences from companies like Amazon, Microsoft, Adobe, Google, etc. So what are you waiting for? Code Studio has a lot of free resources for interview preparation. The link will be in the description. Make sure you check it out. Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. Recursion, yes, one of the toughest topics for the beginners is what I'm going to start today. So it's going to be an entire playlist. Do you need to know any prerequisites? Yes, there is a slight prerequisite. You should be knowing what is a function. Yes, what is a function? Like, how do you write a function to add two numbers? You should be knowing that much. If you know how to write a function to add two numbers, that is more than enough to watch this playlist. Will this playlist be in C++ or in Java? Doesn't matter. Just watch this, because I'm gonna write pseudocodes and I'm gonna explain the entire concept. So language will not matter. C++, Java, Python doesn't matter. Okay, so to start off with, what is a recursion? Let's read the first line. When a function calls itself, very important. When a function calls itself. That means if I'm writing this function, and inside this function, there is this function being called again. So this is what is the definition of the first line. So in order to understand this first line in depth, how does it work and everything, let's take a super quick example to print 1 using a function, like using a recursive function. And once you have understood how recursion works, then we can understand the second line, which states until a specified condition is met. So generically there is a main. If you're using Java, that's a public static void main. If you're using C++, it's an int main. So if there is a main and I'm saying a function, let's assume I write the function as f. Okay, this is what I'm calling, and the f function is a void f function, which says, hey, can you please print 1. In C++, it's going to be cout. In Java, it's going to be system.out.println. And I call the same function again. So how does the program runs? First, the program comes to the int main, the execution. Then it comes to the f. And whenever you're calling the function, it straight away goes and calls this function void f. Okay, so I am going and calling this function void f. Now the void f goes and prints this line 1. Yes, it executes this line 1. So I can say if I'm having an output screen, on that output screen at this moment 1 will be printed. Okay, after this line is executed, which states calling of the function, like calling of the self function f. So how will this work? Will it again call back like this, or how will it work? It eventually calls back the same function, but in order to understand in a much better way, what I'll do is, I know like if I just write it over here, there's a problem. So I'll just create a replica of this function and I'll write it over here. Okay, so I'm calling the replica of the function print 1 and again f. So this f again calls the same function. So basically it calls the same function again, because this function is in your memory, right? So it calls the same function again. And again this first line, yes, again this first line is executed. So again there will be an output of 1. And again after this particular line will be executed. So how will this particular line get executed? It again calls the same function in memory. So if I write down the f function again, print 1, f again. So this f will now go and call it. Perfect. So again this line will be executed, print 1. So again you print it 1, and again this line will be executed, which again calls one more same function in the memory, which is void f, and again it prints 1, and after that again calls f. So this, if you write the program, this keeps on going for every day. Why? Because there is no stop condition. Yes, there is not a condition where you say, okay, wait, you're no more going to call me again and again and again. There is no such condition. Thereby, if I keep on writing, this will keep like this will keep calling someone, again this will keep calling someone, again this will keep calling someone, and this will keep on going forever. So it's a non-ending recursion, or I can say an infinite recursion, because you're calling the function again and again and again, and there is no specified condition mentioned where you say that, hey, listen, now you're gonna stop. So if there is no specified condition mentioned, it's gonna fall under an infinite recursion, goes on calling, goes on calling. So if I show you this in my code editor, by the way, this is a Sublime text editor that I use. If you want to use the same format, you can use my watch my video how to install a Sublime text. So this is for Sublime text. This is the int main. You can write it in Java as well. Print is calling cout of 1, which is again a print statement, and again print. So if I run this, if I just have a run on this, what will happen is it will print unlimited ones till it runs out of memory and throws a segmentation fault, because it just, see, it did print so much, but after this it did ran out of memory, because the program cannot keep on running. So this is what we call as stack overflow. Now what is stack overflow? Let's understand. Let's come back to the code. So if I show you the code, this was the main, correct? This was your main, and this main called this f, right? This main called this f, and after this f called this guy. So this f, yes, this f is not yet completed. This function call is not yet completed. So it will be waiting in the memory, correct? So the wait, so there is a stack. Yes, there is a stack. You don't need to know any specific definition of stack. Just, you can just take it as a thumb rule. There is a stack. Whenever you read data structure algorithms in the next chapters, you'll understand what is a stack. But let's understand this function call. Yes, this function call calls this f, which indirectly calls this. So this function call is waiting. Why? Because this function call has called this. So this will wait. Where does this function call wait? I can say this function call waits in line number 2, because the line number 2 has been called and it is waiting. Now this function call is called, over here you're calling this guy. If you see, you're calling this guy. So apparently another function call with line number 2 is waiting. Now this function call is called, again this guy is called. So another function call at line number 2 is waiting. So if you just keep on calling them, yes, if you just keep on calling them again and again and again, so these particular function calls will be waiting in memory, because they are yet not completed. Now when do you call a function to be completed? If the last line has been successfully executed, but this has not been, because this called this guy, hence the last line has not been completely executed. So this is the wait. This wait is what we call as stack overflow. Now remember, if you keep on calling, like in the example in the Sublime text, you kept on calling. It went print 1, print 1, print 1, and at the end it stopped at 523,037. Like it's compiler independent. So in some compilers it might go beyond that. So it did stop. Why? Because this particular stack space would be keeping f. Yes, would be keeping another f, would be keeping another f, would be keeping another f. But this has a specific memory. It cannot just keep on compiling up a lot of function calls, because these function calls are yet not completed. So it cannot just keep on piling up in the memory. So that is when the segmentation fault happens, and it's commonly known as stack overflow, when there is numerous function calls waiting due to recursion, because you call the recursion, So one function call was waiting. You called another, you called another, you called another. So it kept on waiting. This is what we call as stack overflow. Got it? So this is why infinite recursions are not written, because you'll end up having stack overflow. And this is the stack space. Like these function calls are waiting. So in short, this is the definition, or the first line definition, when a function call calls itself. I hope you have understood how the function call calls itself. Now we are going to understand until a specified condition is met. What does this mean? Now if you carefully observe, we call this, then this guy called this, then this guy called this, then this guy called this, then again this guy called this, then this. It will keep on going, but there has to be a condition where you stop calling. Now, that condition is something which is known as base condition. Yes, base condition. So let's quickly write down the function. So assume I'm writing an f, okay, and just assume there is a global variable. I've kept it as count equal to 0, a global variable, okay, and over here I'm writing print count, and I'm doing a counter plus plus, and I'm calling the function. Okay, now if I keep on doing counter plus plus, what will this function like? I've already told you from the main. If I call this function, what will happen? Can you think what will happen? Yes, I think you can. This function call will ultimately call this guy. Then the print of count will happen. And what's the value of count? Initially 0. So the output screen will print 0. Correct? The output screen will print 0. Next, counter plus plus will happen. So the counter value will change to 1. And after this function will again be called to f of 0. And again print of count will be called. But this time counter value is 1. So 1 will be printed. Again you'll do a counter plus plus. So counter is increased to 2. Again you'll call this function. And again this will call someone else. So it keeps on going like this. And you'll be doing print count, counter plus plus again, and again f. So you keep on doing, and again print of count will print the next 2, counter plus plus will make it 3, and again this will call. This will keep on going. Now you need to stop it somewhere. So the condition that you use to stop it is known as the base condition. Yes, the condition that you use to say that, hey listen, you're no more gonna call it, you're gonna stop. So assume I say that we're going to print only up till 3. Assume I'm saying you are going to only print up till 3. So how will you modify it? So you'll basically say function. Let's understand how this works. Right at the starting of the function, you're going to say, initially the count is 0. You're going to say if count is equal to 4, I am going to return. Okay, I am going to return. I'll explain you this as well. I'm going to return. Else, I'm going to print count. I'm going to do a counter plus plus, and I'm going to call the function. And in the main, I'm going to call this function. So if I ask, how will this work? Let's understand. So let's first keep the output screen. Let's see how this works. So I'm saying function. This function is called via main. So it goes and calls this particular function. What's the first line? Counter is equal to 4. Is it? Counter is 0. So counter is not equal to 4. Perfect. Next, goes to the next line which says print count. What's the value of count? The value of count is 0. So you print 0. Correct? Next, counter plus plus. That means counter becomes 1. This line is executed. Next, function has been called. So in the stack space, this function will be awaiting. This function will await in the stack space. So in the stack space, this function, which is the line number 1, 2, 3, 4, 5. In line number 5, this function awaits. Why? Because it goes and again calls the same function in the memory, which this time checks is count equal to 4, and then returns. Print again the same thing, count, counter plus plus f. This time is count equal to 4. No. Print count. Count's value is 1. So to make things simpler, let's keep count as 2 so that we don't have to print a lot of times. Or count as 3. Count as 3. Let's keep count as 3 so that we don't have to print a lot of times. So counter is printed. Again counter plus plus. So this line has been executed. Function has been called. So the moment you call the function, this guy, yes, this guy goes into the stack space saying that, okay, another function call at line number 5 awaits to be completed. So you again go and say f of if counter is equal to 3. Is it? Counter is 2. So it's not. So this line is still not executed. You will print counter. Then you will do a counter plus plus. So print counter will be executed. Prints. Counter plus plus makes it 3. And then again you'll call the function. Okay. Now this guy will again go into the stack space saying I'm still awaited to be completed. And this time this function call will again call some other function. But this moment counter equal to 3 and counter is, if you carefully observe, counter is indeed, yes, counter is indeed 3. Counter is indeed 3. So you can say that this line, yes, this line will be executed and you will say return, and you will say return. Thereby all these lines, like all these lines will not be executed. All these next 3 lines will not be executed, and the moment you return, this function is terminated. Remember, if you're writing a return statement inside a function, the function gets terminated then and there. So this says, okay, I'm over. So this function called this, but this is over. Now the moment you come over here, this guy gets out of the stack space saying, okay, it's time to be executed. So this line is over now, and this time it comes over here, and now it goes back. Why? Because the function call is over. If the function call is over, you can directly go back. Next it comes over here again. You can say this is done. Again goes back because this function call is again over. Now this is also completed. Goes back to the f, and this line gets completed. So this is at the end completed. So what happened was you called, and this guy said I'm over. Went back. This is what we call as a specified condition, because you specified that counter has to be 3. Only till then, keep calling. The moment the counter was 3, if you carefully observe over here, the moment the counter was 3, you said stop and return. You stopped it. You no more call this function line because you stopped. And due to that stoppage, the other guys also completed their function calls. And this time there was no stack overflow because you did not call any further than 3 recursion calls. So this stop condition is what we call as base condition. Now remember, there can be a single base condition, there can be a multiple base condition. I'll be talking about all of them in the upcoming video. But I am assuming you have understood the entire stuff. I'll try to code this up. So if you see the code, now this time what we will do is, we'll keep a counter variable as 0. Okay. And what we are doing is we are printing count, and we have something like count is equal to 3, then you can simply return. Or else you can see out count and do a counter plus plus. This was the code. Now let's run it this time. So if I run it this time, you'll see just 0, 1, 2 being printed because print went on and called the functions. And this is the simple dry run. Now, what is the recursion tree? Now there's something in recursion which you'll be hearing a lot. Recursion tree. Now, if you carefully observe, in order to explain you, I wrote the entire function, then I again wrote the entire function, then I again wrote the entire function, then I again wrote the entire function. But will someone do this every now and then? No. So this is basically truncated into a very simple thing, what we call as recursion tree. So basically I'll say the first function was called, which is specifically this guy, and then this guy called F. So this guy again called F. Then this guy again called F. And then this guy again called F. So again called F. But this guy returned. This guy, if you carefully observe, this guy returned. So what you'll do is you'll return. So you went, and you returned, and you returned, and you returned. So instead of writing the entire function, we basically represent them in terms of F. Okay, and that is what we call as recursion tree. We'll be talking about depth in recursion, like I'll be doing a lot more problems, so you'll understand what is the concept of recursion tree. So basically, the same function call is what I've represented in a smaller representation, and that is what we call as recursion tree. So in order to summarize the class, I hope you have understood everything, like what is recursion, like calling the function within itself, infinite recursion. After that, you have understood what is a base case. The moment you say that, hey, listen, you are not going to perform the below lines, you go back. There's no more recursion being called. Go back. So that is what the base case is. You also understood what is a stack overflow, a stack space. Stack space is the space where the remaining non-executed functions, like non-completed functions rather, because this guy was called, so this function was yet to be completed. So stack space stores the yet to be completed ones, and there is something which is known as recursion tree. It's basically the diagram in which the function calls someone, then that guy calls someone. It's basically a shorter version of the diagrammatic explanation that I gave you. So I hope you have understood all these three things. Okay, so in the next video, I'll be doing couple, I think 3 or 4 problems. I'll be learning recursion in more depth. So just in case you have understood recursion in entire depth, like the theory concept, please make sure you like this video. And if you're new to our channel, please do consider subscribing. And yes, if you haven't yet checked our Strivers SD sheet, the link will be in the description. Please check it out, because a lot of people are getting placed using that particular SD sheet. And yeah, with this, I'll be wrapping up this video. Let's meet in the next one, where we will be solving some problems from recursion. Bye bye, take care.